previous session, we shall continue our study on ratio, proportion, similarity, and congruency. This is part 2. Please, it is highly recommended that you view part 1 before you view part 2. It is highly recommended. So in this session, let us talk about some of the vocabulary words we mentioned in part 1. We are going to look at a postulate or axiom, and then we will also look at theorem. So we mentioned this in part 1 among the vocabulary words. We shall do some problems on this in part 2, and we shall also solve more problems on the ACT on similar figures. So what is the difference between a postulate is the same thing as an axiom. What is the difference between a postulate and a theorem? With a postulate is a proposition. Is a proposition you can take down. It is a proposition that is generally accepted without proof. Okay, with a postulate, we accept the proposition without proof. But a theorem is a proposition that is generally accepted, but with proof. So that is the basic difference between a postulate and a theorem. With a postulate, it is a proposition. We do not need to prove it. We just accept it that is true. And a postulate is used as the basis for proving theorems. You can use it as a basis for proving theorems or proving the validity of arguments. But a theorem is a proposition that has to be proved. We have to prove a theorem. Okay? So that is the main difference. Now, let us look at a theorem on similar figures. Let's look at theorem on similar figures. Theorem on similar figures. So, when let me call this theorem 1. Theorem 1. So, when I mean similar figures, it means similar triangles and other similar figures, quadrilaterals, okay, pentagon, similar polygons. Yeah, when I mean similar figures, I mean similar polygons, That is what I mean. So, with this theorem on similar polygons, we look at the perimeter. Let's say we have two similar parallelogram. Okay. So I call this ABCD, parallelogram ABCD, and parallelogram EFGH. So we say parallelogram, and of course, you know, with the parallelogram, the sides are congruent. Two sides are congruent, or two sides are equal. Now, parallelogram ABCD is similar to parallelogram E, F, G, H. So the theorem we will talk about now is that the ratio of the perimeter, if two polygons are similar, and you can write down, if two polygons are similar, then the ratio of their perimeters is proportional to the ratio of the corresponding sides of their corresponding sides. Okay? If two polygons excuse me if two polygons are similar, the ratio of their perimeters is proportional to the ratio of their corresponding sides. Or you can say to the scale factor. Remember, we talked about scale factor. To the scale factor between them. Scale factor. So, if two polygons are similar, the ratio of their perimeters is proportional to the ratio of their corresponding sides. When I mean corresponding sides, I mean the corresponding side lengths. Okay, the lengths of their corresponding sides. Side is the same thing as length of side. Okay, or you can put it this way: if two polygons are similar, then the ratio of their perimeters is proportional to the scale factor between them. Because scale factor is what? Ratio of their corresponding sides. The ratio of the corresponding sides of two similar figures is what we mean by scale factor. We defined it in part 1 of the video. So what is this saying? This is saying that the ratio of their perimeters, so line segment AB plus line segment BC plus line segment CD plus line segment AD all over, this is the perimeter of the first polygon, which is first parallelogram, all over line segment EF plus line segment FG plus line segment GH plus line segment HE or EH. Okay? This is the ratio of their perimeters. Is equal to the ratio of their corresponding sides. Or you can say ratio is proportional to the ratio of their corresponding sides, or is proportional to the scale factor between them. So this will be line segment AB over the corresponding side is line segment EF, which is also equal to line segment BC over line segment FG, which is also equal to line segment CD over line segment GH, which is also equal to line segment AD over line segment EH. So this is the theorem here. On similar polygons, it applies to similar polygons, not just similar triangles. Okay, this applies to similar polygons. Okay, so if we have, maybe let's say we have this as A, B, C, D, and we have this as E, F, G, H. So what we are saying is that A plus B plus C plus D all over, that is the perimeter, all over E plus F plus G plus H is equal to A over E is equal to B over F is equal to C over G is equal to D over H. That is what we are saying. Okay, theorem 1. This applies to similar polygons. Okay, let's solve some questions. Let's solve a question. This one is ACT 1996 form 52C. ACT 1996 form 52C. That is this one. And here it says here, just begin from the number we stopped on video 1. I don't know how many did we solve in video 1? Let's see. Yeah. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay, we solved 12 problems in video 1. So this is question 13. Question 13. It says here, the two triangles are similar. The two triangles are similar. Angle A is congruent to angle D. Of course, remember we said for similar figures, the corresponding angles are congruent. And number 2, the corresponding side lengths, the lengths of the corresponding sides are proportional. We mentioned that in part 1. Okay. So it says here, angle A is congruent to angle D. What is the perimeter? What is the perimeter of triangle DEF? DEF. So we have these two triangles. We have two triangles here. We have triangle ABC and triangle DEF. ABC and then DEF. So here is 5, 3, 6 and this is 15. So this is the question here. You are asked to find the perimeter of DEF. The perimeter. Okay, so we will look at two ways you can do this. We will look at the usual way that some people might want to do it, right? Because some people will say, okay, let them use the definition of similarity to find this length, line segment DF and line segment DE, and then they will add the three lengths to get the perimeter. That is what some people will do. First method, and that is a long method. So it is still correct for if you are not working with time. Okay? If you are not working on that time, then that is the method. If you want to use, that's fine. Okay? So let us do that. Let's do that, and then I'll show you the easier method. So because this is ACT question, and with ACT, it is not just that you got it right, but how fast you are. So you want to use the any valid shortcut to make sure you attempt all questions and get it right. Okay, but usually this is the side facing angle F is the small f, and the side facing angle E, and this is how we do triangles. Whenever you have triangles, the side is the lowercase letter, and the side facing angle E is lowercase e. The uppercase are the angles, the lowercase are the sides. That is usually how we write triangles, the sides and the angles. So from the definition of similarity, remember, for two polygons to be similar, number one, the corresponding angles must be congruent. So angle A will be congruent to angle D, angle B will be congruent to angle E, and angle C will be congruent to angle F. That is first requirement. Number two is that the lengths of the corresponding sides are proportional. Okay, so 5 over F is equal to, because that is the length of the corresponding side, equal to 6 over 15, equal to 3 over E. That is the second requirement. So we can use this 5, we can first of all do it with this. This means that 6F is equal to 5 times 15, and the F will be 5 times 15 over 6. So 3 into 6 is 2, 3 into 15 is 5. So this is 25 over 2. F is 25 over 2. Okay? F is 25 over 2. And then we can also do 5 over F equal to 6 over 15. 6 over 15 equal to 3 over E. So 6E is 3 times 15. E is 3 times 15 over 6. 3 into 3 is 1. 3 into 6 is 2. So E is 15 over 2. So the perimeter would be the perimeter of triangle DEF would be 15 plus 25 over 2 plus 15 over 2, which is 15 plus 40 over 2, which is 15 plus 20, and that is 35. Okay, 15 plus 20, and that is 35. I will not encourage you to use this method in ACT. Okay, if you want to use it, that's fine. But, I will encourage you to use a shorter method. So second method okay? Short method. Is we did the theorem, okay, that the ratio when two figures, and that applies to polygons, not just triangles. Okay, that applies to excuse me, that applies to polygons, not just triangles. When two polygons are similar, then the ratio of their perimeters is proportional to the ratio of the corresponding side lengths. The ratio of the lengths of the corresponding sides, or ratio of their corresponding side lengths. Or you can say is proportional to the scale factor between them. So in this case, we already know the perimeter of that. So 5 plus 3 plus 6 all over the perimeter we need. Okay, let's call perimeter of triangle DEF. Perimeter of triangle DEF, because that is what we were asked anyway. So is equal to 6 over 15, and that is it. So 5 plus 3 is 8 plus 6, 14. So 14 over triangle DEF, the perimeter of triangle DEF is equal to 6 over 15. So the perimeter of triangle DEF is 14 times 15 divided by 6, because this is 6 times this. I want you to work. Right now I am not taking the test, so I am taking my time to show my work. Okay, but when you are taking the test, just know that you can just do 14 times 15 divided by 6. And since you are allowed to use calculator, you can. Okay, so perimeter of triangle DEF is 14 times 15 over 6. 3 into 6 is 2, 3 into 15 is 5, 2 into 2 is 1, 2 into 14 is 7. So this will be 7 times 5, which is 35. The same thing. Okay, but this one is shorter. Okay, and you are working ACT, 60 questions for 60 minutes. So, so we are done with this one. Next one. Next one, let's solve some problems on similarity, and then we are going to go into postulates. We will go into postulate. So we are done with this one. Now this one here is 1996 from 52C. 1996 from 52C. Question 14. Question 14 for this video, not in that, the question 14 is this video, not in the paper, but this is 1996 from 52C. An architect is drawing a scaled blueprint. An architect is drawing a scaled blueprint of an apartment building. That is to be 150 feet wide and 200 feet long. That is to be 150 feet wide and 200 feet long. On the drawing, if the building is 48 inches long, on the drawing, if the building is 48 inches long, how many inches wide should it be? How many inches wide should it be? So this is similarity. It is similarity. So it's proportional reasoning. Okay, you can call it proportional reasoning if you don't want to call it similarity. But it's the same building, so it is proportional reasoning. And we talked about this in part one of the video. So this would be so you have scaled blueprint. You have the scaled blueprint, right? And you have the drawing. You have the drawing. So here, the length, you have the length and the width. You have the length and the width. So the actual length is 200 long and 150 wide feet. And here, the building here is 48 long, and they're asking you for the width. Let the width be x. So you see, it's proportional reasoning. Proportional reasoning. So you can do, you know, with proportions you can write it several ways. With proportions, you can write it several ways. You can write 200 over 48 equal to 150 over x, or you can write 48 over 200 equal to x over 150, or you can write 200 over 150 equal to 48 over x. With proportions, you can write it. You can write it these four ways. Or you can also write 150 over 200 equal to x over 48. All these will give you the same answer. All of it will give you the same answer. So if we do this now, we can pick this one. We can pick this from here. If we do cross product, we see 200x is 48 times 150. So x will be 48 times 150 all over 200. And you can use your calculator to save time. You can use your calculator to save time. In some cases, 0, 0, that is gone. 4 into 20 is 5. 4 into 48 is 12. 5 into 5 is 1. 5 into 12, 5 into 15 is 3. So x is 12 times 3, and that gives you 36 feet. 36 feet. Proportional reasoning. Okay? Question 15. Question 15. So we cross off this. Question 15. We have this one here. I'm going to mention a theorem, and then we're going to do, and then we're gonna do more problems. Okay, I mentioned a theorem again. Of course, with the theorem I want to mention, you already know it in triangles. You already know it in triangles, right? And I'm doing that so we can solve more problems here. Some of these questions, they need another theorem. They need another theorem. Okay, so I hope you know that when you did this in triangles, so you already know this. If you have an isosceles triangle has two equal sides and also two equal angles. Okay, when you have an isosceles triangle, if you have it this way, that means this and this are congruent. If you have it this way, that means this and this are congruent. This is with isosceles triangle. If you have it this way, that means this and this are congruent, right? You already did this. You did this when you did triangles. So let us solve more problems before we go to postulates on similar triangles. So question 15, you have a bunch of them. They ask it a lot. They ask it a lot. They ask it a lot. You have a bunch of them. So we're gonna have, we will have more parts to this. I will finish teaching all the theory now, not theorems. I will finish teaching all the theory, and as I teach it, we do problems. Then, when I finish with the whole theory, then we will now solve all questions on a similarity and congruency in your ACT. So, let's just solve more problems on similarity. So, you have this one, April 2016, form 73E. So this was just last year question. April 2016, form 73E. So you have that triangle ABC is similar to triangle DEF. Sides AB and BC are each 7.2 cm long. Then line segment DE, of course these are line segments, which is also side. DE is 10.8 centimeter long. 10.8 centimeters long. Angle E is 42 degrees. What is the measure of angle C? What is the measure of angle C? So they drew the triangles, they drew it, triangle ABC and triangle DEF, triangle ABC and triangle DEF. Please, what I recommend, before, the question before you solve, before you pause it, okay, I will write it now, and then I want you to pause it. Then try it on your own, okay? Try it on your own. This is 42 degrees and this is 10.8. So pause this now and solve it. This is what they're asking here. That is what they're asking. Angle C. That angle. So I want you to pause the video, try to solve it, then you play it back. So they already told us it's similar. And with similar, remember, with similar, the corresponding angles are congruent, and the lengths of the corresponding sides, or you can say corresponding side lengths, are proportional. So you see here that this is 42 degrees, right? And because this is 42 degrees, remember ABC is similar to DEF. So angle B is also what? 42 degrees. Angle B is also 42 degrees. Reason. Now, in the class, I want you to tell me these reasons. Because with geometry, anything you write to show your work, in ACT you are working with time, so you don't need to write reasons. But in the class, when I ask you this in class, I need you, anything you do, you tell me the reasons. So angle B is 42 degrees. Reason is that corresponding angles are congruent. Corresponding angles are congruent because of the similar triangles. So this is 42 degrees here. 42 degrees. Now, you now see angle A is equal to angle C. And you can call it X. Let's call it X. Okay, let's call it X. Reason. These are the base angles of isosceles triangle. Are equal. This is the reason. Remember, this is an isosceles triangle. It has two equal sides. So this is like saying that this is like this, because these are the two equal sides. And because of that, this and this are equal. Okay? So we call it base angles of isosceles triangle. So we say let it be X. So in this case, we now have that X plus 42 degrees is 180 degrees. Reason, sum of angles of a triangle. Sum of angles of a triangle is 180 degrees. So you see, if you don't put the reason, I take away points. I will, yeah. You will have anything you do in geometry, you got to have a reason. Now, ACT, no problem. You just solve. But here, you gotta give me reason. In the class test. So this is 2x plus 42 is 180 degrees. So 2x is what? 180 minus 42. Which is what? 10 minus 2 is 8. 7 minus 4 is 3. 138. Right? So this implies that x is what? 138 over 2. So x is 2 into 13 is 6. 12. 18 is 9, 69 degrees. And that's your angle C, 69 degrees. Okay? Now, let's do question 16. Question 16. So, we knock this off. Question 16 is December 2015. December 2015. December 2015 from 72E. December 2015 from 72E. It says here, in isosceles triangle, isosceles triangle PQR, line segment PQ is congruent to line segment QR. The measure of angle P is 54 degrees. Angle P is 54 degrees. What is the measure of angle Q? Find angle Q. Angle Q. So this is the triangle here. This is the triangle here. So you have PQR. PQR. And this is 54 degrees here. So they're asking you to find angle Q. This is what they're asking you to find here. Question mark. Okay. Now they say that PQ is congruent to QR. So PQ and QR. So this tells you that this, let me use yellow marker, that this is congruent to this. That is what it tells you. And because of that, you see it is this and this. That means it is this here. That this will be 54 degrees. Okay, because these are the lengths. This is this. That angle R is 54 degrees. So, but I would like you to write reason. Reason. Anything you do, you write the reason. So angle R is 54 degrees. Reason, base angles of isosceles triangle. Base angles of isosceles triangle. Because this PQ is congruent to QR. So I know I didn't draw it to scale. Okay? Because this looks longer. Right? This looks longer. I didn't draw it to scale, so now then you now have that angle Q plus 54 is what? 180 degrees. It's 180 degrees. Reason, because this now is 54. Okay? Reason, sum of angles of a triangle. Sum of angles of a triangle. You have to know these reasons. You have to. You have each one, you give me a reason. So now angle Q will be, and that is not for ACT, but for you to know why you are doing it. I want it. Okay, you have to show all work. So this is 180. 54 times 2 is what? This is 108 equal to 180, right? So angle Q is 180 minus 108. Okay, 10 minus 8 is 2, and this is 7. So angle Q is 72 degrees. That's it. Okay, the next one. Question 17. We've knocked off this one. You really have a bunch of these here. You have a bunch of this here. Okay, another one is this. Okay, this one is December 2014. December 2014, Form 72G. December 2014, Form 72G. It says in isosceles triangle ABC, in isosceles triangle ABC, line segment AB is congruent to line segment BC. The measure of the vertex angle, they did not draw this one. It's just word problem. They did not draw it for us. The measure of the vertex angle, angle B is 75 degrees. Find the measure of angle A. Find the measure of angle A. So they did not draw this for us. So we have to draw it. So but they told us that this is a vertex angle at the vertex. Okay. Triangle ABC. So if we draw this, it will look like this. ABC, B is 75 degrees, triangle ABC. And they say that line segment AB is congruent to line segment BC. So this and this. Okay, so this is isosceles triangle. So this is equal to this. And let us call it X. Let's call it X. Okay? Let's call it X. They want us to find angle A. So the same thing, the same way we've done the rest. You see, they like asking it a lot. They like. And in this case, they did not draw it for us. They did not. So you should be able to draw the triangle if they did not give it to you. So we see that angle A is equal to angle C, which is X. Reason, base angles of isosceles triangle are equal, okay, or are congruent. Base angles of isosceles triangle are congruent. So, then we now say X plus 75 is 180 degrees. Reason, sum of angles of a triangle. So we have that 2x plus 75 is 180. 2x is 180 minus 75. This is 5. 105. Is that right? So x is 105 over 2. X is what? 2 into 10, 5. 2.410.5. 52.5 degrees. Make sure you put your degrees. Make sure. If you do not put degrees, I take away points. So 52.5 degrees. Okay, question 18. So we knock off this. Question 18, I'm making sure that I answer everything I can answer before we go to postulates. Question 18 is the same year, December 2014. Would this one be postulate? Yeah, well, it's not. Okay. So this is December 2014 from 72G. December 2014 from 72G. So it says here, in rectangle, ABDE, C lies on line segment BD, C lies on BD, and F lies on AE, and F lies on line segment AE, such that rectangle ABCF is similar to rectangle CDEF. Okay. Find the area of rectangle ABDE. Okay, so you have this rectangle here. You have two rectangles here. They gave you this question, they gave you the diagram. Okay. So this is A, B, C, D, F, E. F, this is F, and this is E. I hope you can see it. This is F. Okay? A, B, D, E. You have two rectangles here. I mean, if you can say three rectangles, okay? You have three rectangles here. Rectangle ABDE, rectangle ABCF, and rectangle FCDE. Okay? But they say that rectangle ABCF is similar to rectangle CDEF. Okay? Then you have 4 here, and you have 8. You have 4 and you have 8. Find the area of rectangle ABDE. The whole rectangle, the area. Okay, so we don't know this. We know that this is 4 by looking at it anyway. By looking at it. But we don't know what is this here, CD. We don't know line segment CD. We do not. Okay, by looking at this, we know that line segment CF is 4. But let us not go by that. Well, we can go by that anyway, I'm sorry. We can go by that line segment CF to be 4. But how do we find line segment CD? How do we find it? Okay, so let's look at this here. Let us look at this. They told us that rectangle ABCF is similar to rectangle CDEF. Now let me say this, please listen. Even if they did not give you the diagram, no problem. No problem. Okay? If they give you this is the main thing. If they give it to you. If they give you this is the main thing. Even if you did not see the diagram. But they told you that this is congruent to this. Fine. That is what you should be interested in. That this is congruent to this. So, what this means that angle A is congruent to angle C, if they say that this is similar to this, I mean, this is the main thing here. Even if they don't give you the diagram, but they say that this is similar to this, you can just, this information is enough. Okay? You will see that angle A is congruent to angle C, angle B is congruent to angle D, angle C is congruent to angle E, and then angle F is congruent to angle F. This is the number one requirement for similarity. The congruent angles, the corresponding angles are congruent. The corresponding angles are congruent. Then the second requirement, the lengths of the corresponding sides are proportional. So line segment AB over line segment CD is equal to line segment CF over line segment EF. Okay? Line segment AB over CD is equal to CF over EF. Okay? Then you can also have BC and DE. So another proportion is line segment BC over line segment CF is equal to, or you can say line segment BC over line segment DE. You know there are several ways of writing proportions, Yeah. But let's write it from the main requirement. Corresponding side lengths are proportional. So you can say BC over DE is equal to CF, right? Line segment CF over line segment EF. So you can form the proportions. But now they gave us the diagram, so we should be looking at the diagram as well, because they gave it to us. But even if they did not give it to us, even if they did not give us this diagram, and they told us that this is similar to this, we can write the requirements right away. The congruency for the angles requirement and the proportions for the side requirement. Okay, but they gave us the diagram, so we have to use it because they gave it to us. And this now they are asking us for area. Area of a rectangle is length times width. Okay, area of a rectangle is length times width. Length times width. So we now have to find CD. That is our problem. We have BC is 8, BA is 4. What we have to now do, because now DE and BA is the same thing. AB, okay, and ED. From here, you can see that this is 4. But the problem we have now is finding CD. That is the problem we have. Looking at this, you see that this is 4, this is 4. But we are looking at area of AB, DE. So this is 4. We really don't need this. We don't. But our problem is to find this. Once we can find the length, this is the width. And once we can find the length, we find this. We now find the length and we multiply it. So how do we find CD? How do we find CD? We know AB, which is 4. We are looking for CD. We know CF, which is 4. And we are looking for EF. So this here will not help us per se. It's not going to help us because it's like saying the same thing. 4 over x is equal to 4 over x. Yeah. Let's call this x. Let's call it x. Let's call it x. So we come over here. Let's look at this. We know BC 8, DE is 4, then CF is 4, and then EF. So this is what we're going to use here. We have to use this one here to now find that x. Okay? So, when we do that, we have that BC is 8 over DE is 4 equal to CF is 4 over EF. EF, we call it X. EF and CD is the same thing, X. So, if you look at this now, 4 times 2, if you want to do cross product, that's fine. But you're working under time. You're working under time. 4 times 2 is 8. So what will you multiply by 2 to give you 4? You see that X is 2. X is 2, just like that. Just like that. But on your test, because you can look at this proportion, 4 times 2 is 8, therefore 2 times 2 should be 4. Okay. Now, but on the test, you have to show your work. So 8x is equal to 4 times 4. X is 4 times 4 over 8. 16 over 8, so x is 2. Now we can now find the area. We can now find the area of rectangle ABDE. So, area of rectangle ABDE, area of rectangle ABDE will be, the length is 8 plus 2 times the width is 4, which is 10 times 4, which is 40. And you put the unit, okay? Whatever unit they give you, you put squared. Yeah, let's say maybe the unit is centimeter squared, you know. You now put centimeter squared if the unit is in centimeter. And that is it. Okay? Question 19. Let's do question 19. This one is gone. Question 19, we have, question 19 is December 2013, form 71E. December 2013, form 71E. So we have this, we have this here. We have a triangle. We have this. A, B, they are asking for this here. C, F, E. This is 31 degrees, 31 degrees. Okay. Now they said line segment AB is congruent to line segment BC. Then they say line segment AE intersects line segment BF at C. What is, find angle B. What is the measure of angle B? Find angle B. Find angle B. That. So, this is your knowledge of triangles. You have done triangles. So, your knowledge of triangles is important. That's number one. Is that, when did I say triangles? Well, yeah, knowledge of triangles is important. Isosceles triangle. And number two is vertical angles. Your knowledge of vertical angles. We call it X angles. That's what we call it, X angles. Okay. So if you have this, the AB is congruent to BC. So this will be here. This will be this. AB is congruent to BC. So this is isosceles triangle. It's isosceles. So we can call this X and we call this X. Okay? So, and then we are asked to now find angle B. As usual, whatever you do, you give reasons. So, angle A is equal to angle C, and we call it X. Angle A is equal to angle C, or because angle C is so many, you don't want to write it like this. You do not. Okay? You don't want to write it like this. Why? Because angle C is so many in this case. So you can write it this way. You can write it this way. Angle BAC is equal to angle BCA and call it X. Okay, this means angle at the center. So angle BAC is equal to angle BCA. You call it X. Reason, base angles of isosceles triangle. Isosceles triangle. Okay. Now, our X is equal to 31 degrees. You know that, right? This is your vertical angles. Vertical angles. Vertical angles. So, vertical angles, informally, I call it X angles. You know, that is what I call it, informally. I call it X angles. This is equal to this. This here is equal to this. When you have two intersecting lines, two lines that intersect. So it is they are vertical angles. So X is 31 degrees. Now we now see that 31 plus 31 plus angle B, you can call it ABC, equal to 180 degrees. Reason, sum of angles of a triangle. Sum of angles of a triangle. Okay? So this is a 62 plus angle ABC is 180. So angle ABC is 180 minus 62. 10 minus 2 is 8. 7 minus 6 is 1. 118. Okay? So angle ABC is what? 118 degrees. Angle ABC is equal to 118 degrees. And that's the answer. Okay? So question 20 is next. 20 questions so far. So we've knocked this one out. Do we have another one before we go for? Yeah, we have another one, and then we can now do postulates. We have another one, and then we can now do postulates, and we can call it a day. This one right here is April 2015, ACT, April 2015, Form 73G. April 2015, Form 73G. So you have the border of a pool and the border of a patio are similar rectangles. The border of a pool and the border, sometimes the word problem is too long, so I just shorten it so that this video I know you will say, this video is very long. Of course. And the border of a partial are similar rectangles. As usual, please pause whenever I ask question, pause it, then solve it on your own before you play it back. Are similar rectangles. So find the length of the pool. They said several things, but I cut it short here. Just find the length of the pool. That's the main thing. Find the length of the pool. They said so many other stuff. Now let me say this. Those word problems they give you in ACT, try to paraphrase it. Because they give those lengthy word problems sometimes to throw you out. You see it, it's too much. Oh, no. But when you read it, just take time and read it. After you've solved the easy questions anyway, take time, read it. You will see that it's not difficult. It's not. Paraphrase it, shorten it. So they said so many things here, but I shortened it. So you have this diagram. They gave us a diagram here. They gave us a diagram here. Two rectangles that are similar. They call this partial and they call this pool. And this pool, they had water in the pool. Okay. They put 28 here, 28. Then they put a question mark here. This is the pool. They put a question mark here, question mark. We can call it X. They put 40 here, 40 for the partial, and they put 60 here. So this shouldn't take you long at all. This one shouldn't take you a long time at all. Okay, so you can say 28 over 40 equal to x over 60. Okay? You can say 28 over 40 equal to x over 60. Or you can say 60 over x equal to 40 over 28. Or you can say, you know how many ways you can write proportion. Or you can say x over 28. You can also say x over 28 equal to 60 over 40. Okay? Or you can say 28 over x equal to 40 over 60. Several ways you can write proportion. But the main one is, these are all right. All correct, no problem. But the main one is that the lengths of the corresponding sides are proportional. So the main one is saying x over 60 because this is the corresponding side length equal to 28 over 40. That's the main one. So if we do that, what do we have? We can actually do it here. How about it? Let's do it here. X over 60 equal to 28 over 40. Okay? So this means what? This means that 40x, this implies that 40x is 60 times 28. So x is 60 times 28 over 40. This implies that x is 60 times 28 over 40. Okay, 0 cancels 0. 4 into 4 is 1. 4 into 28 is 7. 4 into 28 is 7. So x is what? 6 times 7. X is 42. And they gave you the units. So just put the unit. They gave you the units. You put the units. x is 42. Okay, this means this implies that when you have this, it means implies. If you have this like this, it means implies. So anytime you see me write that, it means implies. Now let's look at postulates on similar triangles. Let us look at postulates on similar triangles, and we shall solve some problems and we can call it a day. So take down postulates on similar triangles. So number one, we have what we call the AA postulate. AA postulate. Angle postulate. Angle postulate. What is this talking about? You can write down the angle postulate states that, remember this is on similar triangles. The theorem we did was similar polygons, which includes similar triangles. But this is just similar triangles. So the angle postulate states that if two angles of a triangle are congruent to two angles of the other triangle, okay, any two angles of a triangle are congruent to any two angles of the other triangle, then the triangles are similar. If two angles of a triangle are congruent to two angles of the other triangle, then the two triangles are similar. So let us look at this for a moment. I'm going to use simple triangles, okay? Simple ones. But just know that they can twist it. So you have triangle ABC and you have triangle DEF. So I will use colored chalk here. I'm going to use, let's say, I use yellow one here, angle A, angle D, and I'll use blue here, angle B, and I'll use double lines, just to show. So this is what angle postulate is all about. You have two angles of triangle ABC are congruent to two angles of triangle DEF. This shows that triangle ABC is similar to triangle DEF. So you can write this down. If after writing the English, now let us write the math. If angle A is congruent to angle D and angle E is congruent, angle B is congruent to angle E, then if then in programming, conditional statement, then triangle ABC is similar to triangle DEF. Okay? And we shall solve problems on it. We shall solve questions on it. Number two, we have the side angle side postulate. Side angle side postulate. Okay? Side angle side postulate. So you have a side, you have an included angle, then you have another side. Side angle side postulate. Okay, with this one, we look at a side, we look at now two sides of a triangle, and it has to have an included angle, and it's what we call an included angle. So let's draw this. I'm going to use ABC. Now keep in mind that they can twist this. The main thing is for you to understand how it works. And don't worry, we shall solve questions. We shall solve ACT questions on these postulates. So you have triangle ABC, you have triangle ABC and triangle DEF. Let me draw this so I can have space. Triangle ABC and triangle DEF. DEF. So I will use a yellow chalk here, side, side. Then I'll use an included angle, white chalk, included angle. And I'll use a blue for the other side, side angle side. Side AB, angle B, and then side BC. Then here, I use the yellow chalk here, side DE, white chalk, angle E, and then a blue chalk, side EF, Okay? So that is, you notice this side, included angle side angle side postulate. So take down, if the lengths of the corresponding sides of two triangles are proportional, if the lengths of the corresponding sides, or you can just say if the corresponding sides, if you don't want to put length of sides, length of side is the same thing as side. Okay, when we talk of side, we mean the length of the side. So if the length of sides, if the length of the corresponding sides, it has to be corresponding. If the lengths of the corresponding sides are proportional, let me repeat. If the lengths of one triangle, if the lengths of two sides of one triangle, or you can say this, you can say it like this. If the lengths of the corresponding sides of two triangles are proportional, and if the included angles are congruent, if the lengths of the corresponding sides of two triangles are proportional, or you can say if the corresponding sides of two triangles are proportional, and if their included angles are congruent, then the two triangles are similar. Okay? If the lengths of the corresponding sides of if the lengths of the corresponding sides of two triangles are proportional, and if their included angles are congruent, then the two triangles are similar. Okay, so that is what we did here. So you can see that triangle ABC is similar to triangle DEF. Triangle DEF. Okay? But you see there's an included angle. Angle B has to be congruent to angle E, the included angles. And the lengths of the corresponding sides are proportional. Okay, number 3, the third one. The third one is the number 3, we have the side postulate. Side postulate. Side postulate. So let's have a excuse me, triangle ABC and triangle DEF. Triangle DEF. Okay, I'm gonna use the 3 colors I've been using. So AB, let me use yellow here. AB, yellow. DE, yellow. Side DE, yellow. BC, I leave it as white. EF, I leave it as white. And then AC, I use blue. AC, I use blue. And DF, I use blue. Okay? So, the side postulate. Okay, let us stop here for today because the video is already too long. Okay, I want it to be, I know it's long, I know, but let us stop here for today, and next part 3 we shall solve more questions. Okay, we shall solve more questions on this, and then we shall also look at more theorems on similar triangles. We still have more theorems. Alright, thank you so much for watching this video, and if you have any questions